In this example, we're going to start working with characters. Right? So exercise 4 asks you to write a program to determine whether the character entered, so pay particular attention to the wording, the character entered, not the integer, not the number, the character entered by the user is a numeric digit. Do not use the isdigit function. So if you're familiar with programming, there is a function that will do this for you. We're going to write it ourselves. And then in example 5, I'll show you how to use the isdigit function as well. Right, so it tells us the problem. Look at the ASCII table. Notice that all the numeric digits are stored consecutively in memory. Let's just pop open an ASCII table here. So numeric digits, numeric characters. Right, so here the character 0 is represented then by a hexadecimal 30 or a decimal 48. Right, so if we type a 0 in memory, we're going to see that there's a 48 stored there, or the character 0. Consecutively in memory means, right, we can start with the number 48, and 0 through 9 go 48 through 57. So this means we'll be able to check to see whether the character we type in is within a certain range. Right. Let's go back to code blocks now and implement this. All right. Let's finish up our comment and start our C program. Right, we're gonna go ahead and use well, we have to have the user enter something, so we're going to need standard.io.h. All right. Input variable. This time needs to be a character type, so a char. I'm just going to call it cval. Right. And we're going to prompt the user, so enter a numeric character. Right. Scan F, we're going to store it. Now, because this is a char type, we're going to use %C. We want to read this in as a character, not as a number, but a character. All right. We want to store that at the address of our variable cval. Right. And now what we want to do is we want to determine whether it's a numeric digit. There's different ways we can do this. One way we can do this is we can literally say if cval is greater than or equal to the character 0. So notice when I use a character constant, I have to put it in single quotes. And cval is less than or equal to the character constant 9. This is why it was important that they're consecutively in memory. So if it's within this range of values, we're going to say it's a digit. And we can simply then say F %C is a numeric digit. And substitute in there for our cval. Right. Maybe put a blank line. And then we might want to tell the user, if not, we might want to just say else. Is not a numeric digit. So let's take a look at this. Oh, I need to move this old file to my project. Just have this one. All right, let's do a run to cursor here. All right, so it's showing the last program I ran over in the watch window now. It'll update in a second. One of my favorite things about this current version, 16.01 of code blocks, but we'll live with it. All right, enter a numeric character. Well, 0 is a numeric character, so I'm just going to type 0 and hit the enter key. Right, so see what it shows in memory for cval? It shows the character constant 0 with a single quote around it, but it shows the decimal value of 48, right? If you remember from the ASCII table, 0, right, has a decimal value representation, a base 10 representation of the number 48. So we should find then, of course, that this is true, that this is a numeric digit. So next line, obviously that was true. It meets the condition that it's both greater than or equal to 0 and less than or equal to 9. Right, and we'll print out the message that that was a numeric digit. Right. Similarly, let's run this. Why that breakpoint's annoying me, but I'll ignore it for now since it's not going away. All right, let's run this by putting in a non-numeric digit. The letter A is not within that range. So notice here, it shows the character A. That's a decimal 97 if you go back to the chart and check that. All right, next line, well, that's false, so it's going to print out that it's not a numeric digit. Right. Fairly simple program to write, taking into account that we're using character values, right? We're trying to just read a single digit, not a whole integer, just a single digit at a time. Check that digit and tell it whether or not it's numeric. All right, let's stop the debugger. Let's show you how to do this with a switch case statement as well. Now, the switch case statement we're going to find to be more cumbersome. Right, it's a lot easier, we'll see, to check a range of values like this than with a switch case. So what we want to do is we want to switch on cval, right? If you can write an if statement and you're trying to figure out what you should be doing in your switch statement here, well here, right, you're checking the value of cval every time. So you just want to have cval in there. And we just want to check to see then if cval, well, we could say case 0, that's true, right? We could say case 1, that's true. Case 2, oops. And notice these have to be character constants. Case 3, case 4. See how tedious this is getting? Because I have to type out every single case. Because the case statement sort of treats us like an equality. It's basically saying if cval is equal to the character 0, or if cval is equal to the character 1, or if cval is equal to the character 2, and so on. 6, right, 7, and finally 9. Right, so I think you can see you really would want to use a case statement with this. All right, and then all I want to do is I want to do this. I want to perform the same action. And then I'll break, and then I'll put in a default label. All right, default says if cval isn't equal to any of those cases up above there, then here's the action I want you to take. Well, I want you to print out it's not a numeric digit. I don't need a break after that last default because I'm at the end of the switch statement here. All right, so now same thing. Let's run the cursor. And notice we can check multiple cases. We can have, in this case, I have all these case labels lined up. So if any of these are true, it's going to perform this action. Right, this is basically how we have to do something to check a range. So in this range, all of these could be true, case 0 through case 9. Right? Remember when I typed in the 0 and hit the enter key before, we saw that was a numeric constant. Right? So here we're going to switch on cval. Cval has in that character 0. It's going to find that to be true. It's going to print out that information, break, and drop through here. Right? You can see that in our output. Similarly, right, if we do a run to cursor, right, we type some letter before, I believe I typed the small letter A. notice then we've got the character A in memory, the value of 97. Well, it's not going to be equal. None of these cases are going to be true. C-val's not that. So it goes down to default. Right? Prints out the message saying it's not a numeric digit. Right? And that's the way we can use then ASCII character information to do that. As I said, the case statement is a bit more cumbersome, but it illustrates how you can use character constants as well. Now, what we can do is practice 5 asks you to use the isdigit function. We'll do that in, might as well do that right now. He's doing a separate video. So we're going to write a program to determine whether the character entered by the user is a numeric digit. Use the isdigit function. All right, so Control-Shift-N for a new file. Yeah, I want to add it to the active project. All right. All right, to save some time, I'm going to copy some code from here. All right, let's just copy this. We still want to read in the information here. The program will still need to return 0 at the end of main. Remove 4 from the environment. All right, so let's take a look at the isdigit function. All right, let's go to here, c++.com. I'm going to type isdigit. All right, so the isdigit function, right? We're going to call a function spelled like this. I'm going to pass it, well, this shows an int. Right? I can pass it a character. A character is part of the integer family. Right? And it's going to return an int value to me. Right? So this says checks whether the C, so C is the argument here, the parameter. Checks whether C is a decimal digit character. So decimal digits it defines as any of these characters 0 through 9. Right? And it's going to return a value different from 0, basically true, right? If indeed C is a decimal digit, 0 and false. Oh, okay, so we won't worry about this array. We haven't gotten to arrays yet in this program, but what we're going to see is what we want to do is call if isdigit. It's going to return a value of true is what it told us. What we're going to do here is we're just going to say if, and here we call the function isdigit. We can pass it our C value. And remember, true is any non-zero number. I don't have to compare it to any non-zero number. I can just say if isdigit. Remember, if this expression does not evaluate to true or to false, it will consider this to be true, and then we'll just go ahead and let's, I should copy that other code. We want to print out %C is a numeric character. Else isdigit must return false. Is not a numeric digit, I guess is what we wanted to say, not character. All right, so let's compile. Okay, so it gave me a warning, implicit declaration of function isdigit. Forgot to include the header, which was cc type. And let me make this smaller. All right, so here it tells you what the header is. In our case, it's going to be ctype.h. What this is showing you here is a C++ header. So anytime you see something prepended with C, you know it's a C library. And to include it as a C library, we get rid of this first C. We're going to say ctype.h. Over here, then, right, I need to include ctype.h. Sometimes when I include a library for a function, I'll list that function right here. So now, if we compile this, right, we don't get any errors, right? We can build and run. Let's just do a run to cursor. All right. So numeric character, well, 5 is a numeric character. Let's work with something different. 5 is a numeric character. See, there's a character value of 5. It has a decimal value of 53. We'll find that this is true. If I say next line, that's going to return true, and it'll execute this statement, right? And it'll drop down here to return 0. Similarly, right, if we enter some non-numeric digit, so once again, the character A was a non-numeric digit, right? We're going to see A is a 97. This is going to return false, so it's going to drop down here, perform this action. So there are some nice libraries that will help you out when working with character data, right? But it was good for us to see how to write this ourselves. It really wasn't that hard. We took advantage in practice exercise 4 of the fact that these were all consecutively in order. So it really wasn't that hard for us to write this simple function by ourselves. And the other thing, technically, I should do is the fact is if I was working with all of my warnings turned on, so I'm going back to the fact that it says that this is supposed to be an integer data type. What I could do is I could statically typecast this. So I could, in parentheses, put int. And then for this purposes, instead of treating it as a char, it's going to treat it as an int. So it's going to promote the char to an int. So if a char is an 8-bit value, and this makes this a 32-bit value, it's just going to prepend right to the left enough zeros to make it an integer. So this is called a static typecast when I do that. It says for purposes of this one execution of this line, treat this as an integer. Promote it from a char to an integer. Right? It was doing that already, but if I have a whole bunch of warnings turned on, right, about mismatched types, one of those would pop up if I did. And if I just do a build and run like we did before, just to show you, really nothing's different, right? If I type in the number 5, it's still a numeric digit. Oh, and I completely missed the fact that I wasn't printing this out. My apologies, right? I should have been printing out cval. I'm sure you all noticed we were getting garbage out there. All right, let's run this now. Again, I type in, oh, it's 5, hit the enter key. I've got my 53 here. Next line, this is true. Now when I print it out, I don't have that little garbage character. I've actually then matched the number of arguments I was supposed to have. So here, I had accidentally left out this argument to substitute in here, and we were getting that garbage out before. All right, so that's exercise 4 and exercise 5.